Good morning. So my name is Bill Yaji, and this morning we'll be talking about the WSA, the Web Security Appliance, as well as a side of advanced threat, probably 60% WSA and then 40% advanced threat on WSA. Just a quick overview of what we'll be covering, some troubleshooting on it. We'll go into AMP and threat grid, and a little bit on cognitive threat analytics. So a little bit about me. So I'm a consulting security engineer for Cisco. I've been working there for a little over 8 years, but spent my entire career in the networking security industry. Prior to Cisco, I actually did work for a web security vendor, a competitor of Cisco's, in the advanced services space for a while. And most of my career has been spent on large design and deployments, so generally the Fortune 50 or larger, but I did do some work in the smaller and mid-market as well. And I'm in the Midwest, in between Chicago and Milwaukee, right on Lake Michigan. So if any of you are close, let me know. So within the deck, I do have some slides that we will not be talking about in here. I think you guys all saw the deck, like 160 some odd slides. We won't be hitting all those. I do have stuff hidden. And the reason for that is because we have folks that are on different versions of code. So I have some configuration things that I've hidden that are on older but not super old versions of code that have changed to newer versions, so things like that, and then also a little bit more deep dive into some of the details. As I'm sure you've heard a million times throughout your stint here so far, there are surveys. We do really appreciate the feedback. Our goal is to obviously do perfect on these so that you are interested and want to come back next year. And if I haven't met that, let me know why. Let me know what you didn't like about it. The WebEx Teams app, you've all heard this as well by now at least 10 times. It is a room. I will be checking for questions. I don't have any moderators for this session because I'd rather a more interactive session. But if you do have questions or want to talk to your peers, feel free to jump in the room. It'll be open until the 18th, and that'll allow you to talk to peers, to me, to other web security experts within Cisco as well. So let's dig in. So our first section here, we're going to talk just high-level web security. So explicit, transparent proxies, how they function, how do you redirect traffic, how does the WSA support all those modes, IP spoofing, just a high-level kind of at a glance to get everybody on the same page. Before we jump in, how many in here are actually using the WSA today in production? Okay. And of those, how many are using our AMP suite on that? So advanced malware protection. A lot lower than expected. Okay. So let's jump in here, and hopefully by the end, those who don't have AMP will want to have it on there as well. All right, so let's talk about web security. So explicit proxy. How many in here are using explicit proxy? Okay, so the rest transparent then? Okay. All right, so explicit proxy is actually my favorite method of deployment for a number of reasons. It's got a lot of advantages. When it comes down to it, most web applications support the concept of an intelligent proxy. When it comes down to it, it's a lot easier for a network admin to get traffic to it. You understand the path. It's a very logical flow. You tell the browser to talk to the proxy knows what it's supposed to do. Everything works. You're not messing around with inconsistencies that we see in WCCP, dealing with maybe the networking team, because we know nobody likes to talk to each other. So the security guy or the web focus guy or the content guy doesn't want to have to deal with the network guy to put in WCCP strings into their switches, things of that nature. It offers some generic load balancing without having to have hardware load balancers. Depending on the size of your company, that may or may not be a good idea, and we'll get into that in a little bit. From a security perspective, you can remove the default route on the network, which is a real big advantage to a lot of customers. With the way things are moving to the cloud and the way we're seeing a lot more non-connected, non-proxyware apps, this argument may be going away a little bit. But the idea of a default route on the network is a pretty large security hole for organizations. And then when it comes down to it, if you're doing like a proof of concept or want to deploy WSA in a new section of your environment, it's easy to test because your browser, you can actually just tell it, go to this box that's sitting under your desk, hiding from your security team, and be able to go out and test your policies. There are some negatives. So depending on how you push the proxy pack information or the proxy information to the browsers, it requires a pretty solid Active Directory architecture, which I find in the majority of my customers, nobody really has. So that's one of the negatives, right? GPO policy push is sometimes less than desirable in a lot of organizations. It doesn't sync the way people think it does. All that stuff makes it harder. You'd think it'd make it easier to back out, but sometimes it doesn't, because again, the networking guys don't want to talk to the server guys. It's amazing anything gets done. If you have something that is not on the domain, requires manual intervention, or maybe a browser that's not supported by that. So there are some concerns around there about people being broken because they put in a new app or something, and it's a little bit easier to circumvent. So when we talk about traffic flow on explicit proxy, it's relatively simplistic. The flow is the same whether it's IPv4 or v6, and effectively your browser talks to the WSA because it has that configuration in it, and either the browser or your application, whatever it's going to be, talks directly to the WSA. And in this case, the WSA does all the lookups. So the WSA does the DNS lookups. The browser does not do any lookup except for the DNS name for the actual web proxy. And then depending on how the WSA is configured, and again, when I did this session in Europe, we had a lot more customers using IPv6. Is anybody in here actually using IPv6 inside their network or out? Okay, pretty much what I expected. So I won't focus too much on IPv6 in this session, but you can configure in the WSA that outbound connection, whether it's going to prefer IPv6 or not. So that is a configuration option you have. And then in this case, from a security perspective, you have your firewall being the device that is allowing all the traffic out from the web proxy pool, not necessarily all the devices within the network, which is what you would need to do in the case of it being a transparent proxy in many cases. So we talked about configuration here. Pretty simple. If you're going to use IPv6, the WSA does support dual stack, so you'd have your interface card with both IP addresses on it. You can also configure failover groups, and we'll talk about that in a little bit. And we see that more in our smaller customers who don't want to mess around with proxy pack, who don't have expensive load balancers, who may not have devices that support WCCP. We'll talk about that in a bit. So real simple, you would just configure IPv4 and or v6 for that. So when we take a look at it, you also have the concept of default routes. So the WSA itself has two different sets of interfaces. We have the management interface that can be used for everything, or you can partition off the management interface to do just management type activities. So your Active Directory, got very weird in here. Your Active Directory, your DNS lookups, things of that nature can all go out to management, and then your actual proxy traffic could go out a proxy interface. So depending on how you do that there, you can do default routes and then add static routes in if you want to shoehorn traffic out other interfaces. That has been required in the past for some services on the box, because we have kind of default things where things should go, and you can overwrite those with a static route. So when we talk about DNS, by default, when you do a DNS lookup, because remember, in explicit proxy, our WSA is doing all the work with DNS. So you put in your DNS servers, you can configure priority if you want to have them weighted to a certain place. You can add IPv4 and v6 addresses in here. But in the event that your DNS server provides both addresses, which do you want to prefer? So when you go to look up a certain domain, the DNS server could respond with IPv4 and v6, and you can configure which you'd rather the proxy to use to help shoehorn that traffic out the appropriate protocol. So for my smaller customers, we have a concept called CARP, so Common Address Redundancy Protocol. Think of it similar to VRRP, something that will have multiple devices with a single IP, and then the boxes will, you'll have a virtual IP address that you'd point all your end users to, or your proxy pack to. It does have IPv4, v6 functionality, but they do have to be in the same layer 2 segment. So if you have multiple WSAs, they have to be layer 2 adjacent. You can't have them within different segments. And the way it works is you have basically one master and multiple slave devices. And when it comes down to it, again, this is used in probably my sub 1,000 seat customers. I haven't had too many customers that are using it much wider than that. There's nothing saying that it wouldn't work for that, because the technology would work just fine for that. However, when it comes down to it, a customer that's going to be larger will usually have load balancers and other things in there that would support alternative mechanisms. So when we handle this, you basically create failover groups, and again, IPv4 and v6 are supported. And when you configure it, you tell which of your WSAs is the master, which one are the slaves or the backups. And then effectively what will happen is the IP address that you give and put on all the browsers will be the one that they're advertising. One of those boxes goes down, it will go ahead and one of the others will take over that virtual IP. There are some configurations that you can do, and after you do the configuration, there's other things that you can take a look at to test the failover group and take a look at the functionality, which is the master, which are the slaves, what is the group ID, all that information. So it basically is using multicast for a keep alive between all the boxes and just keeps configuring, it keeps talking with each other to make sure that all the slaves are up, to make sure that they don't stop working. So CARP, again, is one of the ones that's used for my smaller customers. Now, we do have a lot of customers that are using proxy packs. So what is a proxy pack? Pretty simplistic way. Actually, it can be simple, and I'll show a couple simple examples here, but you can actually create some pretty crazy proxy packs with different load balancing, preferring DNS servers, doing all sorts of fun stuff. I find that this is going to be, a proxy pack is going to be generally used in more of our small to mid-market customers, and the reason for that is because they may only have 2 WSAs instead of 15. And depending on, they may not have a lot of load balancing requirements or care about source stickiness, things of that nature. It's basically a very generic text file, and it can be served from the WSA or it can be served from a domain controller. We have customers who do both. And the most simplest example is you just basically give it the proxy, the DNS name, and what proxy port it's going to be listing on. And that's pretty basic. Like in this example, use that proxy over the proxy port 3128 that the proxy is listing on, and everything should be happy. Real simple, right? It will do failover and load balancing. Now, this particular example has 2 proxies, so we have both listed on the same port, and then what we're saying is if 1 doesn't work, it'll try 2. If 2 doesn't work, it goes direct. So that direct statement means that it will try to actually connect to the internet without having the proxy in place, without having any configuration in there for proxies, it'll go direct out. So in the event that you have this type of failover, you would need to have the appropriate firewall and NAT rules to make sure that that traffic doesn't get thrown in the garbage once it gets passed. And also in this case, would require you to have a static route to get that traffic to a firewall or egress point for that. So I've got some examples in here of how to do it. So you can do an if then else, you can hash the URL for basic load balancing. There's other options that you can do here if you have multiple proxies and how you want to do it. There's a lot of different configuration options that you can do for load balancing. And again, I would argue that some of the load balancing functionality within a proxy pack is dangerous because what will happen is some websites will actually break if you change proxies for traffic to the same site. So if you have it load balancing, say, on the destination DNS name, and you're going through proxy A for everything, and then all of a sudden, you've never touched proxy 2 at all today, and then the next page for that site requires you to go to proxy 2, maybe it's an HTTPS page, maybe you're not decrypting, and now it won't authenticate you properly because you're going to a different proxy. So there are some concerns there that you have when you do load balance. It's always best to load balance based on source IP. That way you're not flipping between proxies unless there's a failover. So that covers explicit. Now let's go in to do transparent. So I think transparent was the mode that most of the people in here are familiar with and using or planning to use. So there's some benefits and pros and cons for this as well. So when we get into this now, we take a look at what we've got going on. We've got no need to touch the end user device. This is a benefit in a lot of cases. So you have a workstation, you have iPads, you have iEverythings, everybody on your network, and you grab that traffic based on the type of traffic that it is. You may need to edit some security zone settings on the browser to use authentication and to make authentication work, but when it comes down to it, you're not going to have to actually go in and add a proxy to the machine. Any machine that comes on your network will go through this. Policy-based routing, WCCP, things of that nature are what would qualify for a transparent. The nice thing is, too, you can force the traffic there without your users knowing. So they are less likely to, if they know that you're able to scrape their traffic without that, they're more likely to behave on non-corporate devices and things of that nature. It's easy to do a staggered or staged rollout, so WCCP does support ACLs, so you could say just have this segment be redirected, or just these ports, or just these destinations, however you wanted to do it. You have the ability, load balancing is inherent in WCCP, so at the end of the day, you don't have to buy hardware load balancers or things of that nature. We do have some people who do transparent proxy with a load balancer. That is another option, but if you just have Cisco gear with WCCP enabled, it will load balance and actually weight connections too, and we get into that in a little bit. And it's also very easy to back out. If everything hits the fan, you back out the WCCP statement in the router or switch, and the traffic immediately stops being redirected. So in the event that you're doing a cutover or you're doing some change, it's one command on a switch versus having to push to a whole bunch of machines and you pack to move them or swing them or something of that nature. That said, we've got our list of negatives as well. So nothing's perfect, right? So the negative on WCCP, the very first one, authentication. Authentication can be a nightmare with transparent proxy, especially if you're not doing SSL decryption. When it comes down to it, a browser generally handles it pretty well. A browser knows you're going to have a person going to the internet. You're going to go ahead and have the ability to do authentication in a browser. Like, that's all part of a browser's ability to do it. But we have things these days that are not using the browser for internet access. There's different apps on a workstation. Many of you probably have your software teams, your internal teams, writing horribly coded software that don't support proxies, that don't know how to authenticate, that don't do all these things. And then they wonder why it breaks when they put it on your corporate image and you have authentication turned on in the proxy. So there's usually a heavier use of requirements as surrogates when you're doing authentication. So, and sometimes those can be unfavorable. If you have somebody authenticated in a conference room, they get an IP address, they go to another building, depending on if you're using IP surrogates, what your DNS timeouts are, or DHCP timeouts are, that your user could be somebody else. So there's some problems in there that you have to be aware about. Yes?
What about using the context directory?
So right, so the question was about CDA. So CDA is it pulls the authentication information from Active Directory and then gives that to the WSA. Now CDA, I don't talk about CDA in this session, but CDA is something that we do have a lot of our customers using, and when it comes down to it, there are some negatives there as well, because CDA pulls the information out of Active Directory. Now what will happen is, we see a login and we associate IP address 1.1.1.1 with a user. What'll happen is that user only generally ages out after a timer. There aren't logout events that are shown. So you still could have the same problem there if that IP address is taken by somebody else, that it could show in the logs that it would be somebody else. Now, that scenario is the sky is falling scenario, because it would require somebody to very likely manually put in an IP address to do that, because CDA is not an active authentication. So it gets the information. There's usually like an 8-hour timeout on the data, but that person could have multiple IP addresses throughout the day and only re-updates when you log into the domain. So how many of you are actually logging into the domain more than once in the morning? Like if you go to an IP, you're at your desk, you close your laptop, you go to a conference room, you turn on, you get a new DHCP address, but you're not doing that Kerberos login again. So CDA does have some negatives as well, and that's actually maybe something I'll talk in my next year's session on this. I can put a little bit more about CDA pros and cons as well. Sometimes WCCP can be a real pain in the ass. There's code requirements. Certain versions of hardware support different versions of WCCP. They support different mask or hash, or there's lots of different things depending on if you're layer 2 or layer 3 adjacent. A lot of things around WCCP that require some tinkering to get it to work. The positive thing is once you generally get it to work, it is pretty stable. And again, authentication, especially around HTTPS. Authentication can be a bear on transparent proxy. So now we take a look at what this looks like with transparent. So here, the change is that the DNS resolution is done by the client, because again, the client has no clue that there is a proxy there. So what'll happen is you'll have the browser go ahead and do the lookup for where it wants to go, It'll try to connect to the website just following its normal network path out. Whatever the device is that we're grabbing that traffic with, whether it's a router or a switch or sometimes even a load balancer transparently grabbing the software or grabbing the traffic, it'll redirect to the WSA. Now, the WSA will then proxy the request and it'll do another DNS query. Sometimes we see customers having issue here as well because their internal DNS and the DNS servers that the web proxy are using could be different and maybe giving different results. So that's another thing to keep in mind. Your browsers are doing DNS in one place in some cases, depending on how big your org is, and then you have the WSAs potentially doing it somewhere else and getting a different result. So one thing to keep in mind there when you do that. There are 2 DNS queries that are being done when you're transparent. So we talk about WCCP here. We'll get a little deeper here. So there is the concept of an assignment method, and that's hash and mask. Now when we do a hash-based assignment, it's a software algorithm that determines what WCCP device is going to get all the traffic. So you have all your WSAs that connect to the switch, and the switch determines which box it's going to pair you to. We get into that in a little bit. Now, in some platforms, it can be done in hardware, which actually makes things a whole lot better. And there's 2 types of redirect methods that we'll get into in a second as well. And then you have mask, which mask is completely handled in hardware. So if you have the ability to do mask, that's generally where you want to do it because it's a little bit quicker and a little bit less hurt on the processor of whatever's doing the redirection. So we can do 2 types of redirection with WCCP. So as the traffic is passing past your switch, you can either do a WCCP in redirect, which watches the traffic on the inbound path into the device, or we can do WCCP out. WCCP in is far better because it's hitting the device once, not twice. So when we do WCCP out and we do the output redirection, it passes by, we have to shoot it back in and out. So the redirection device is actually processing it twice. So if you have the ability to do WCCP in, it's a lot cleaner. And I think from a security perspective, it allows you to be very scalpeled in which pieces of traffic you're actually going to pull off the wire versus redirect out. You're basically grabbing everything and then having to send it back through the device. So registration works pretty simply. You've got a WCCP client. So the client here is going to be your WSA or whatever proxy you're using. We hope it's WSA. And then you have the WCCP server, which is going to be the switch or the router, or even an ASA in some cases. So the WCCP client, so the proxy, is going to actually register or try to register to the device, and that configuration is done in the proxy. You create a group ID, and the group ID is going to be shared across all the same WSAs that are in that pool. So if you have 10 WSAs, they all belong to a certain service group. Now it is possible to have more than one service group, and we'll talk about why in a little bit. The one CCP server, the WCCP server, you can have any number of WCCP clients in it. We do have there are no theoretical maximums that I've run into. When you start to get into the dozen to 2 dozen devices, there starts to be some more considerations in how some of the configurations are done. And again, depending on how you're configured determines what load balancing we have. So up until version 10.1 of our code, maybe a year and a half ago, like I said, I've been with Cisco for 8 years, and I've pretty much spent the majority of that time complaining about this lack of this function up until very recently to weight some of the traffic. So by default, WCCP weights equally. So if you have 3 devices, in theory, you're going to see roughly the same software distribution or traffic distribution across all 3 devices, which works great if you have 3 devices that are of the same horsepower. We have new hardware that comes out. You might be a customer who's had WSA for a year or 2. So maybe you have a bunch of S680s. Well, all of a sudden you need more capacity, so now you would go buy a 690. The 690's got a whole lot more juice behind it and can handle more requests. But the way WCCP worked on our gear for a very long period of time, everything was equal. So you had 3 boxes that are sitting at 70% and 1 box sitting at 50% utilization. We've actually changed that, and we'll talk about that in a little bit. But basically the way it works is when you connect all the traffic that's going to the WCCP server, so the switch or the router, It's going to go ahead and create buckets across all the devices, and it's going to equally load balance those if you've configured it that way. If one of those devices goes down, it splits that traffic and sends it to all of them in hopes that they all stay pretty equal. So when we talk about the WSA and its support for all the redirect and assign methods, we support all of them. We do it in software in the WSA. And the key here is that we've got this WCCP weighting. Now, this feature here allows you to have a slew of different size devices in your environment. And you can say, I want to send twice the amount of traffic to this box versus this box. So we call that WCCP weighted load balancing. And basically, it allows us to give an assignment weight to each WSA and allowing that weight to allow more traffic to one or another. So when we look at the configuration, it's just a numeric value that gets put in there. And if the default assignment is 1, and we've done that because if you have older versions of code, so if you have some WSAs running newer code versus older, which we really hope you don't because that's not a good thing to do, but if you do, you would have to have all of them equal because the old boxes do not support the assignment weight, and having all of them in the same WCCP pool will make your day very unhappy. So what'll happen is, let's say in a scenario we have 4 WSAs, and with those 4 WSAs, we give a weight of 1, 2, 3, 4 to each one. So the way it'll work is, if you add that 1, 2, 3, and 4, we get 10. So what'll happen is, 10 is the total number of all of those. Now, the way it works in the hashing bucket, the one that has 1 will get 1/10 of the weight, so 1/10 of the traffic. So you would want to give that weighting to one of your smaller boxes. Now, if we had all these as ones, like if we wanted it equally balanced, you have 1 assigned for each WSA. That's 4, so each one will get 1/4 of the traffic, which is what would make sense. And then if one of those breaks out or goes away, then that traffic is equally distributed among the other ones that are in the pool. So the algorithm's actually pretty simple. Now, we talk about this here. If one of them drops, so let's say our box number 4 drops, now our weighting is 6, so now we get 1/6, 2/6, and 3/6. So one box gets half the traffic, one of it gets 1/3 of the traffic, and one of it gets 1/6 of the traffic. So pretty simple. Is anybody in here using weighted load balancing yet, or has anybody tinkered around with that yet? It is a relatively newer feature. It's been in version 10.5, 10.5 and newer, I think it was. Hopefully you guys use it because we beat the product managers forever to get it. So it is something that we've had a lot of people request. So when we get down to it, we have 2 different types of redirection. So like I said, we create a service ID that bundles all your WSAs together into that same pool. And you have the ability to pick which ports you want to redirect. So you would say, I want to redirect port 80 or 443, or maybe you have some random ports in some of your company's random software. All those would get put into the redirect port numbers up here. Now, we give you options to redirect based on the destination port, which is what you'd want for that outbound traffic, because we're going out to the internet on port 80. Now, we will talk about the return path in a little bit. And then here's an option that we get asked a lot. So how do you want to load balance? Do you want to load balance based on the server address or on the client address? So if you are doing it on the server address, it's going to send all your traffic for Google to one box, all your traffic for Cisco on another box. It's going to take a hash of that destination server. Don't do that. Bad for a lot of reasons. You want to keep source stickiness on your client to web traffic as much as you can. So we highly recommend load balancing based on the client address. So what that means is that your IP, the end user's IP address is the one that determines what proxy they're going to go out. And the reason for that is because if you have users bouncing across proxies, if you're doing an investigation, it's going to be harder because you're looking at different sources. It'll break some applications. If you are doing authentication with WCCP, or a transparent redirection mechanism, and not decrypting SSL, you could have a whole lot of hurt there as well. So the recommendation is really to keep it all together. So we talk about some performance considerations. Doing it masked in hardware is better than doing it in software. Layer 2 is better than GRE. Now you may have necessities that require you to use these. Mask and L2 are the better ways to do it. If the WSA is in a different subnet than your proxies, you're going to be forced to use GRE. And again, some of the WCCP servers have a hard time with GRE. So again, we get back to that matrix of knowing what can be supported where. And in the hidden slides, I have some more information about some of the platforms. So again, use W2 if they're in the same subnet. So again, mask and layer 2 are really the recommendations. So we talk about the service group, so everybody in the same pool or a service group, up to 32 routers per service group and 32 clients per service group can be supported. That's the theoretical maximum. Again, getting up in that level could cause some heartache. So again, keep that in mind when you're doing deployment. So the service definition, that's another key, and I think we talked about this. All the things must be kept together. So if you're using a service group 90, make sure they're all 90. If they don't match, there will be problems. We'll talk in a little bit about doing IP spoofing. That does require 2 service groups. So again, very simple layer 2 configuration here. We won't talk about these too much, but basically you have the concept of enable the routing template within the switch that enables WCCP. You talk about the service group. If there's a list in it, what you're going to be redirecting to it. So the permit TCP here, that's telling us that in that access list, traffic that is destined going from anywhere to anywhere, where it's port 80 or 443 will be in that WCCP pool. Your configuration on the WSA has to match that. And then on the interface on your VLAN, you need to actually add the WCCP redirect in statement. So that redirect in, we're doing inbound redirection, not out. So that's kind of how all the pieces come together. Now, what we do have is we generally will put a separate VLAN for the WSAs. A lot of people are going to be putting those maybe in a DMZ or something of that nature. I see most of my customers today actually putting their WSAs on the internal segments. Again, it's all with what your security posture and network team is going to want to do. IPv6, same thing. We basically would have an IPv6 address on the interface. So you see we have 2 IPs on that VLAN. And then again, we need to have an access list for both if you're going to do it that way. So it's basically showing that's the NE/64, 80, and 443. If you're doing dual stack, you actually need to have different service groups. So this is one area where you need to have different service groups. So you're going to do a service group for IPv4 and one for IPv6, and again, doing the redirect list for both. So that's one thing to definitely keep in mind if you're doing dual stack inside. And just another slide reflecting the same. It's a very large arrow. All right, so when you do configure WCCP, you would put the IPv6 or v4 in the service group when you are creating it. So you tell the WSA which WCCP server it needs to use, it will talk to that, and then it does its here I am, I see you negotiations. So on the switch, you can actually go and take a look and see what's going on. So we see here, and when we look at this, we see protocol version 2.0. So what that tells us, WCCP version 2.0 is doing it on v4. V6 requires a different version. So you can take a look here, you see what our assignment is, our redirection L2 mask. We showed the mask value. This is the calculation of the buckets. There's some hidden slides talking about that as well. So we go to V4, we see, I'm sorry, V6, we see 2.01. That tells us that it's a V6 WCCP configuration. We have L2 and mask, same functionality down here. So one thing I did want to call out on the ASA, if you are using this on the ASA without firepower services, so old school ASA, we only allow redirect in, so that's one limitation on that device. You have to have the clients and the WSAs on the same interface on the ASA. So the reasons for that is because, remember, the ASA looks at all its interfaces as different segments and different, the ASA is a firewall, right? So it's not a switch where different VLANs are generally not different security groups. So with the ASA, you have to have them on the same device. So if your users are coming in on the inside interface, your WCCP devices, the WSAs, need to be on that same interface. You can't have the WCCPs in a DMZ when you're using an ASA. So we talk about IP spoofing. So what'll happen, it's mostly in transparent mode, And what happens is this is where you want to keep the client IP address the same. So when it goes out, by default, the WSA is going to NAT the transactions. All the transactions outbound are going to look like it's sourcing from the WSA IP address. In some companies, we have people who want to have the internal IP address visibility at the firewalls or a downstream network device after the proxy. So what we can do is we can keep that. So we would spoof the IP address out. So we keep the internal IP address going through. What that requires us to do is actually do 2 WCCP redirection statements. So what happens is going out, we're going to redirect the traffic going on the outbound path. So the traffic from the client out to the internet, we're going to redirect to the box. Now the WSA is going to send that traffic out with this client's source IP. So what'll happen there is when that traffic comes back in, this router up here will want to send it directly to here, but we need to snag that traffic on the inbound path. So what we do is we actually create 2 different service groups and we change our redirection. So on the outbound, we talked about redirect on the destination port. So this is the outbound on port 80. On the way back in, we want to redirect based on the source port because what's going to happen is that traffic is going to have a different port coming out of the WSA. So we want to redirect on the port to grab that traffic going back so that the WSA can send it back to the user. So that's something that's generally used when you want to keep that source IP information at the firewall. Bill's personal perspective, I think this is a real pain in the butt because if you have to do packet captures and things like that, it just really muddies the water in troubleshooting. So again, some security groups require it, some don't. So let's jump into performance troubleshooting. So we talked about the architecture. We understand explicit transparent. We know how stuff can get to the proxy. Now, what happens when the proxy gets slow and things go bad? So where do I look? What type of performance monitoring is on the WSA? How much can you get yourself in trouble with bad policy? Code level, right? Code level is pretty important. We'll talk around some of that. So there's a whole lot of things where they can go bad, right? So you've got a workstation, you've got a bunch of routers that you probably don't manage, that you have a network team who does it, and they don't do anything wrong. And then you got the proxies that you might have on new or old code. You've got DNS servers and AD servers that might not be working well. All these different things, right? So we could have the issue just on the WSA request out. Maybe WCCP is broken. In between the router and the WSA. So now we've got the traffic to the WSA. Well, now what can go wrong? Well, WSA talks to a lot of external services. It needs to do DNS. It needs to do authentication. It might be looking up, CDO information from ICE. Maybe that service is down. Maybe it's sending traffic to DLP. All these different things can slow down the transaction. We have the WSA processes. So this is where you can hurt yourselves. Maybe you have some very inefficient policy on here. Maybe the policy is not configured properly. Maybe it's doing something different than you thought it would. We go to the firewall. Now we got those security guys. What have they done to your traffic? What's broken over there now? No? Oh. So you have all these pieces, right? Okay, well now, let's say everything's all good in your side of the world. Now we throw it out into that dirty internet cloud. Now what can go wrong, right? Everything. So where can the problem actually occur? So you have all these different things, all these things where something can go wrong. Well, where do you start, right? Where do you start troubleshooting? So, you get a help desk call. And this is my daughter, and that's the look I get whenever I ask her anything these days. She's was probably 6 here, and now she's on 13, going on 40. I still get that same look. So what happens when stuff goes bad, right? So who's affected? Is it like one group of users? Is there a segment of users? Are they in a building that could have something going wrong? Are they on a particular policy? Different things like that. Like who is affected? What are they looking for? Are they all going to the same site? Are they going to the cloud? Because the cloud never breaks, Are they going to certain sites? Is it a certain application? Is it a certain vendor that you're doing business with? Maybe the vendor decided to change their access list and now they're blocking you. Or maybe your security guys changed the outbound IP address and now you're coming from a different IP, breaks all your applications. Could be any number of different things, right? When does it happen? Is it all the time? Is it during lunch break? Is it when people are in the morning, buying their chocolate-covered strawberries and, looking at the sports scores from the weekend? All these different things come in. And, well, did this work before? Did something change? Did the desktop team all of a sudden throw a new antivirus patch out that has messed up the machines and now those things are churning away? But the internet's broken, but there's 30 other things that could have gotten in there. So the first thing I would walk through is I take a look at the architecture, right? This is where I feel that the proxy deployment, explicit and transparent, has the big key, right? So what type of proxy deployment are you doing? Are you authenticating? Is HTTPS enabled? Does HTTPS redirection, is it actually working? Did something change on the switches? What features are turned on? Did you turn on a new security feature and maybe something's misconfigured there? What does your policy look like? All these different things roll through. Now we have some things on the box to help you do this. So there's some commands called like proxy stat, right? We can pull the CPU information on the device. We can see the utilization, how many requests per second are being hit. There's a status detail command. You can look at the number of active connections and response times. Now there's some inherent limitations, I shouldn't say limitations, but numbers in the box that if you're getting on high on the active connections, you could see some slowness. We generally say that CPU utilization above 80 to 90% is where you're going to see your most problem. Now, I will say that CPU utilization on the proxies is not linear. You will see CPU and memory being high even when there's no traffic. And the reason for that is there are databases that are being loaded. You have our WBRS database, the categorization databases. There are things there that are running that are going to have memory at a certain level. Do you know what your norm is? For the folks in here who raise their hand that they have a WSA in play, do you know what those stats look like on a good day? You shouldn't be shaking your head, Ethan. You should know what they are on a good day. That way, when it's a bad day, you know what your norm is. If you don't know what your norm is, how do you know where to start when something goes wrong? It'll help you point your fingers at other people faster if you know what your norm is. The proxy connection backlog, and again, response time. Response time is something that I have customers, like some will have a response time of X milliseconds or Y milliseconds. And they're like, well, is this good or bad? I'm like, you tell me, what's your norm? Where does it normally sit? I don't know if your DNS servers are overwhelmed. If the proxy is waiting for a DNS response, that slows your overall transaction. It's not the WSA at all. Maybe your authentication servers are overburdened. Maybe you have the configuration for authentication on the WSA. You're not using surrogates, and that WSA is beating the crap out of the Active Directory servers doing authentication all the time for every HTTP request. All these things can occur, but again, consistency is key, and knowing what those baselines are will help you when stuff hits the fan. So now we do a packet capture, because that's what, the network side of us is always going to want to do a packet capture. The WSA has the ability to do packet captures on the wire, to go ahead and take a look at traffic between the WSA and servers. You can put filters on it. You can do all sorts of things to be able to keep that packet capture file small. If it's not a lot of traffic, like if it's not a production server or it's happening during non-peak times, don't bother filtering it. You can get a lot more data that way. If it's real heavy, which it probably is in a lot of your cases because nobody does test environments, why would we have a test environment? Which, by the way, I will say, anybody in here who has licensed WSA hardware, you are eligible to get the virtual appliances at no cost. It's part of your licensing pool. So for all your, when you have a slew of hardware, If you want to have a test box and you have the ability to have, an ESX server or even an Amazon AWS, if you subscribe to that, you can get a WSA V, which is the virtual appliance, included with your subscription. Not have to pay anymore and actually have a box to do some of this testing on we talk about. So there's something, tidbit of the day. So again, a predefined filter is going to actually help some of that troubleshooting. So let's talk about some issues here that can happen. So if slowness is only occurring during peak hours, likely a capacity issue. You have the lunchtime rush or everybody in the morning. So the route there is that requests per second are likely too high. And we have graphs on the SMA and the WSA as well as those command lines that would show it. So if you do see RPS issues, you might need to bite the bullet and buy some more hardware or augment with the WSA V. Again, the WSA V is that ability to get you additional capacity without having to outlay the cost for hardware. So that allows you to add more capacity to it. And again, we have WCCP waiting now, so that if you do have maybe an older proxy or you buy a newer one, the newer one can get the traffic that it can actually handle without messing around with that equal load balancing. So if the issue actually occurs while you're trying to troubleshoot, because we know that that always happens, the problem is always when we're going to go look at it, try bypassing the WSA. If you have a firewall where you have a default route, you can actually get it, drop it out of WCCP, or maybe have them try it explicit. Maybe you have that test proxy that's not being burdened with all the traffic. Have them point to that. Run it through there to do your packet captures if it's an application issue. That is one of the best things. So when I worked for my previous employer and I was doing advanced services around deployments of the proxy, we would do that. We would have a separate port on the proxy to send people to for the troubleshooting. Makes the packet capture a whole lot easier. Maybe you have a test box that you can roll their traffic through. That way, when the application is doing something unnatural, you have the ability to see it easier. If it's still happening when you bypass the WSA, you can start to wash your hands of the problem. It's probably not you if your only role is the WSA. If it's transparent, try explicit. Vice versa. Is there a load balancer in the way? Maybe the load balancer is overburdened. Could be a WCCP problem or a layer 4 redirection problem. All these are different places to kind of move your mind to think as you're going through. And again, the capacity issue is always potentially a problem, right? So you want to check to see if there's a capacity issue by using that rate command and going through there. The packet capture. If the delays are coming from the WSA, rule it out, check out the track stats. That's another command that you can pull, and we'll talk about that in a little bit. And you can actually edit your access log. So you have the access log in the WSA. We'll talk about this in a little bit as well. You can add certain fields to it to give you more information about what's going on, like the latency field or the response time field. That will let you see across all the transactions, is my latency just on certain domains or is it everywhere? That helps you know if it's your box or somewhere else or something on the internet. You've got SNMP. We support SNMP 1, 2, and 3. We have different MIBs out there that you can pull. So once you have SNMP enabled, that gives you more visibility into the box. There are some stats there that are pretty useful, like the proxy CPU. Want to keep an eye on that. That'll help you know your baseline. I'm sure you've got lots of management tools, different SIM tools that you're using in your environment. Your WSA should be part of it. I cannot tell you how many of my customers are not monitoring their WSAs at all. It's mind-blowing to me. But for every server, they can tell you everything down to the resolution of the monitor attached to it, but they can't tell you what the CPU is on the WSA. Add those to those tools. And again, consistency is going to be the key in the alerting on it. The request throughput, that's another field to watch. That's going to show you how the response time through the device. Ignore the word cache in these. Customers get confused in this all the time. It just means that the values are stored in the cache on the box is all it means. It has nothing to do with caching. So again, we take a look at just using SNMP walk. We get these different integers. We can go ahead and track these. This is an old school way of doing it with SNMP walk. I'm sure you have much prettier tools than this to be able to do that with. So you've walked through everything. Now what? So the CPU's dying. Proxy stat shows it. Your SNMP shows that stuff's wrong. You're at maximum capacity. Your boss says you can't buy any more hardware. You don't have any ESX boxes you can go to because the price of, many of my large enterprise customers, for them to get some services on a VM server, it costs them more than buying the hardware through Cisco. And it takes 6 months to get one. And now you got to deal with those damn server guys. So now what do you do, right? You can't get any more gear, high latency, now what? Well, let's take a quick refresher on policy, because policy is something you can control. And policy is somewhere where a lot of you get in trouble, because we allow you to do a lot of things. We also allow you to do things that can get you in a lot of trouble. We have identification policies. We all know what those are. That's basically the who, the what, the how. How do we identify an end user? Is it the wireless VLAN? Is it the guest users? Is it people we're going to authenticate? All that information is stored in your identity policy. You have your access policies. Access policies tells where people can go, who can surf the fun stuff on the internet and who can't. Your decryption policies. What are we decrypting? Are we decrypting banking? Are we decrypting, what are we decrypting on? How are we decrypting? You have routing policies, which basically tell the box maybe about an upstream proxy. You have outbound malware policies, inbound malware policies, data security policy. Are we talking to DLP? Maybe our DLP server is part of the problem. All these different things are there. So we have all these policies that we have control in the box that can either make your day very good or very bad, depending on how you use them. So let's talk about identities. You want to keep identity usage to a minimum. So the goal of an identity at its most basic level is to determine, who do I want to authenticate? So when it comes down to it, in most cases, you're going to have a big bucket of users that are your normal users. Corporate image, regular people, nothing special about them. They get authenticated. They're using the corporate browser. Everything should work swimmingly well because they are on a very defined workstation. Well, then we have all the outliers. We have the incident response and security guys. Maybe they have machines that they don't want to be authenticated because they're doing pen testing or they're doing things outside of the norm and they don't want to have authentication. Maybe it's a wireless LAN network. Maybe you're in a hospital institution and you have guest segments. I mean, everybody has guest networks, right? Are you running them through the WSA? You're not going to authenticate those. So you separate your groups at the most basic levels here. You can do it by source IP address. You can do it by a number of different things within the policy. So the concept of all identities, you want to use it sparingly because what happens is the way you view the policy within the confines of the GUI and what actually happens on the back end is quite a bit different. So when you use all identities in that policy, it actually mimics the policy in the WSA's back end a number of times. So you're putting more hurt on the box so that every packet that goes through it goes through this whole policy. Your most used, least complex at the top. It's a top-down first match approach, just like a firewall. That applies for the access policies. So you want to have your most, all your little corner cases up top, least complex, and then you have all those flow through. So the idea is you want to get them in and out of policy as quickly as possible. The most complex rules with regexes, maybe with custom dictionaries that have regex, things of that nature. You want those at the bottom, because the idea is those are the corner cases. We want to use those the least. The people who are going to Google and all the normal apps and all that stuff, you want to get them out of policy right away. I've had customers who want to do individual user policy. It was a 150,000 seat customer, and they wanted to have this 100 people get this policy, this 1,500 get this. It was a nightmare. They had close to 45 access policies in their policy, and this was before we started getting really granular. The Active Directory is your friend in some cases, and this would be one of them. So what you do is, the way I suggest building policy is, you have Active Directory groups for a lot of the nitty-gritty of the categories. So what you'll have is, you'll have some manager that wants to overmanage his people. Well, I don't want my people to get to eharmony.com. So then they send a request, and I want to block eHarmony for my group. It's like, okay, and then you'll see the administrator puts it in as a rule, right? So this guy's team can't get to here. Two big problems with that. So one, what does a guy have against eHarmony, right? You have Match.com, you have all the other ones. So why just one? Why would we do a custom category for certain sites when we have WBRS categories that have that in? Why is one dating site bad but not all of them? So the answer to that policy, and to make it easier on the WSA, easier on your admins, is to create an access policy that says if they're in this Active Directory group, they get denied access to the dating category. So then what you can do is, one, you get to wash your hands of it and throw it to somebody else. And then in the WSA, the policy is not changing as often. So there are ways to make your policies a bit cleaner so that you don't have to go through and keep touching everything and changing everything. So access policies are a big area where things can be improved. And TAC, yes? Right. Okay, so the question was around complex policy where you have different groups and devices that need a bit more granular access. Would that be a fair summarization of your need? So when it comes down to it, the response that I would give there is, it sounds like you have different populations of users in your case, right? Are you limiting them by anything else that you can define? By IP segments? By device type? I think you mentioned phones, like Google phones. So you can do policy based on the user agent within the device. So you could have a user agent for those that would potentially give them a different policy. So that's one way. The other thing coming down to it is, what is the actual goal you're trying to accomplish in limiting them? So I have seen in some cases, you may have a call center. Well, the call center people are there to answer calls, not sit there and sit on Facebook all day. So in some cases, a call center might have a very defined list of all of the sites they need to go to. You almost have the opposite problem. I think you need to take a look at the policy and define where these users want to go and why you would want to have such granular access. If at the end of the day, categorization is becoming very table stakes, right? The internet is so big and broad. New sites come up all the time. You have sites being hosted in the cloud. Like you can't just go like we could 5 years ago and say, allow Cisco.com and allow them to get to our content. If you just allow Cisco.com, unless you're using the referral headers features, and that might be something in the policy that might help fix some of your problem. Things are being hosted in the cloud. They're being hosted on another date. You know, it's all over. So if the goal of that user population is to keep them off the porn, keep them off the gambling and the hate and all the bad/fun stuff on the internet, make those policies for that, and then block them there, and don't worry about the real granular access. Let WBRS, the scoring that keeps them off the real malicious sites, and keep them off the categorization sites that are bad, and it might be a lot easier on your policy. If you want, hang around after and we can talk a bit more about your particular use case, but those are things that I would do at a very high level to go ahead and keep that working that way. So we talk about custom categories, and this gets into his ask as well as others, is what do we do there? So there are the predefined URL lists on the appliance, right? So we have your pornography category, your webmail, your gambling, all these different categories. So we have customers who will be converting to us from, insert competitor name here, and they have this nice big blacklist with hundreds and hundreds of domains on it. And they just want to take that and import it over and throw it into our box. And they want to make a custom category to do so. Run those through the device first to make sure that we're not already categorizing those. No categorization is 100% perfect, right? I'm not going to say ours is, I'm not going to say Blue Coat's is, I'm not going to ding WebSense for theirs. Everybody has different ways of categorizing sites, different categories, the whole deal. You want to keep your predefined URL categories to a minimum. Use those for where you need to override Cisco's classifications for some of those. Use those for a triage, right? You get a new list of domains from some government agency that are now bad that we might not have yet. It happens sometimes, not all the time, but it can. And you want to block those. So maybe use that in a block category. So don't use a custom category for stuff that we're already categorizing unless you disagree with it. And if you disagree with it and your argument is logical, the customer's right most of the time, we might have it categorized wrong. You can get that fixed rather than putting in a Band-Aid in a custom category. So if you are seeing a lot of uncategorized sites, this is an area where we do have customers who have trouble. They say, well, 20% of my sites are uncategorized. And we have some customers who do, I think the most horrible thing is block uncategorized sites. That's dangerous. That can make your life a lot of hurt. Yeah, it's not fun. So what'll happen is if you say, well, I'm gonna block anything that Cisco doesn't know about. Okay, well, billsboatingpictures.com, that I have out there that really I'm the only one who cares about, not a single other person in the world wants to look at. Well, that's very unlikely to be categorized by Cisco. Very low traffic, right? It's just a couple pictures, nothing, no big deal, right? But if I want to get to it, I can. So now you have to do in a custom category to say, allow this site. It's a whole lot of back-end work on your part from an administrator perspective, and then it's a whole lot of work on the box as well. Well, the submission around that, you can submit them to get categorized, and we may or may not categorize. Because again, that database, there's always a line in security where, one, it's impossible for us to categorize every single site on the internet. We can't do that, right? Nobody can. Because well, you can keep pushing. Because that site will come up and then go away, and the database needs to be clean, and you don't want the database so big that there's too much bloat in the box, there's time to go to the cloud to do the lookups, a number of things that can get messed up there. So what you want to do is we have a feature on the WSA called WBNP participation. So what that'll do is that actually sends your uncategorized sites up to Cisco. So if all of a sudden we see that everybody's interested in billsboatingpictures.com now, because we see from your company you're submitting them, and from yours you're submitting them, the more hits we see on stuff, the more likely it's going to be included in our databases to be categorized. And also helps with all those uncategorized sites as well. So for customers who have an uncat issue, and you've made the Bill's comment poor decision to block uncategorized sites, that will lessen some of your pain. It won't make it go away, but it'll lessen it a little bit. So when it comes down to it, you have custom categories, right? Well, we can do these in regex. Who in here feels they're completely capable of doing a regex statement that's clean? Yeah, that's what I thought. Yeah, so, regex, sure, go ahead. Only use them if you have to, but, use caution with it. Don't have a lot of categories. Don't have a lot of categories with the match any and the regex. Be real careful with your regex statements. You would want to use the sites field rather than the advanced. So you can do a regex in without doing all the fancy brackets, stars, question marks, all the regex stuff, right? Be clean. Be real clean with it. So we talk about the URL categories. This was something that we added, custom URL categories, and we'll talk about that in a minute here. So we have these built-in ability to pull a third-party feed in. So what this does is it was actually added, the base use case around this was around having the functionality of having the WSA automatically pull lists from a third-party server. So Microsoft Office 365 IP addresses. Everybody's using Office 365. Their IP addresses are changing all the time. They even have a feed that can do it. The WSA can pull that feed, use that in a custom category, and then make sure that that policy is allowed. Well, on the flip side, the customers have asked for, well, I have a help desk where somebody calls and complains about an app that's not working. We want to put it in somewhere quick, not have to go to the WSA guy to get it in policy. So what you can do is you can have a text file where your help desk, whoever, create a web form in front of it, whatever you want to do, can update a policy list and then go ahead and get that updated into the WSA. It'll pull it every X minutes. It'll actually get that you don't actually have to go in and touch WSA policy. The WSA goes out and fetches it from a server. So that is a feed that is done. And again, that feature has been around for maybe a year and a half now. So we talk about decryption policies. So we've got all these decryption policies. What do I need to decrypt and why not? So you want to be careful around decryption. For one, for privacy reasons, right? Your HR or legal department probably has some pretty stringent rules about what you can and cannot decrypt. You want to decrypt for authentication. You have to decrypt for end user notification. If you do a block on an HTTPS site, if you're not decrypting, they get a very ugly, page. You don't get the pretty block page that you have. So you want to pass through sites that are confidential, financial, banking, those. Generally drop traffic that are going to bad sites. No need to decrypt those. And drop categories that match the inappropriate comment. Get those just out of the mix. So we talk about debugging. There is a proxy track log. You can pull those statements through there. It writes it every 5 minutes. You can go in and get those informations. From that, there's a lot of information, a lot of statistics around proxy performance. So what it'll do is you can take these and pull them into your SIM of choice or your tools to watch to get that baseline that we talked about earlier. General statistics about it, throttle transactions, percentages, information around how long the requests are taking. You can watch the statistics and compare the changes between them. It's the number of packet counters. Now keep in mind when the box reboots, these numbers reboot. So we have statistics around the client time. So how long the client was waiting before the request was fulfilled. How long it took to fetch from the client or from the server. All these things are things that are trackable that you can watch, and it will help you determine, is the problem on the internet? Is it on my end? Where does it sit? Server transaction time and wait times. Are we seeing a DNS? Like, are we waiting a long time for the server to send traffic? How long does it take to do a DNS resolution? Is your DNS server overwhelmed? Well, you can watch those and trend those. How long are we waiting for Active Directory? So is authentication bad? Do you go and beat your server guys up? Are we waiting for Cisco to give us a response? Our WBRS servers, how long is it taking to categorize a site? Maybe Cisco's having some problems. So all these different things are things that add a couple milliseconds to each request. All these different pieces. How long is it taking to run through the AV service? Maybe the box is overburdened and the AV scanning on the box is taking longer because there's so many requests going to it. Is adaptive scanning taking longer? How long does it take to determine what I want to do, which engines I want to roll it through? There's different risk scores that are put in as part of this. Now you can put custom fields in these, which is actually pretty nice. So most of these fields can be put into the access log. So if you take a look at the documentation, it's all documented, you can add different things into the access log. Or you can create a new access log with all these things in it for all the requests if you don't want it in your main access log. So for example, in here, we're going to add the authentication time, the DNS time, and the reputation wait time. And you can put in text in those to actually give you an idea when you look at the actual log what it actually is doing. So authentication, DNS, and reputation. How long is it taking to do all those? Basically gives you a human readable local time we have. There's user agent you can add to it. You can actually put in all the Active Directory group memberships. That'll make the logs real painful for you, so be careful with that one, because some people are part of like 1 million Active Directory groups and your logs get super long at that point. The destination IP, where's it going? Well, this is helpful if you're using IPv6 because it would actually show that we're going out over IPv6. So there's different things around there that can be configured. So this is of an example that was put together for a very, very detailed web access log. Again, Maybe you just turn this one on when you're doing problems, or when you're working through a problem. But it's one of those things where you don't want to go ahead and spend all that time, chewing up the logs normally. So basically, what do we learn in this section? Well, the WSA has some pretty detailed logs that you can roll through. The proxy stat is a real good place to start in all these. And really, you control the most of this with your policy. Now, we talk about staying current on code. So how many people are on version 9 of WSA in here? All right, so we'll smack you guys later. All right, what about 10? Do you have anybody on 10? How about 11? Okay. So the reason we want you to upgrade is for a number of reasons. RBU has done some incredible things in the proxy product over the last 2 years. Stability, code, features, a lot. So we talk about new versions of code. So if you're sitting on anything less than 10 right now, when you go home, please put in a request and get those things upgraded. Get them to current code. Especially if you're using AMP, and we'll talk about that in a little bit. If you're using AMP, you gotta stay bleeding edge because we've done so many improvements as we get further along. So when we talk about some of the real key things here, centralized upgrade. How many of you have more than 5 WSAs in your environment? How are upgrades? Go into one, upgrade, go into another one, upgrade, go into another one, upgrade. SMA handles it now, centralized. So centralized upgrade, that's a big one. Weighted WCCP, we got that in 10.5. We've got some more certifications. We go to version 11, we add Hyper-V support. So if you're doing virtual, you have Hyper-V now. If you're using CTA, I know not a lot of you had your hands up for AMP, but you have CTA. We enhanced the support in version 11. 11.5, schedule policy expiry. That was one that a lot of you have been asking for. Cloud lock integration, AMP Unity integration. So if you're using AMP, another feature. And then throughout all of these, performance upgrades. So get upgraded. Now the only key is that if you have an X70, which is pretty old version of hardware, the last code that's supported there is 10.1 on that box. We're not going to be supporting anything beyond that moving forward. There's a question over here? So I think it depends on the features that you're after. Ravi, do you have a comment on that? He had mentioned that TAC is recommending 10.5 right now for stability. Yeah, would you mind doing it in the microphone up here?
So if you are not looking for any specific feature on 10.5.2 branch, I would recommend stay on 10.1.3 for now. For specific bug fix? Okay, then you can go to 10.5.2. No, 11 is still in our LD release.
Yeah, so if you look here, we've got, those are LD releases. They've not gone GA. GA, what are the dates for GA for those?
11.0 will not be doing a GD because all the features of 11.0 are already merged in 11.5. And for 11.5, we are targeting around July timeframe, end of July.
Great. Thank you. Thank you, Sapan. All right, so we have the hardware and virtual appliance sizing. So now let's talk about hardware and virtual. So how do I appropriately size and what options are available? So remember, we talked about this already. If you have licensing for the security features, you get the WSA-V functionality for free and included. So we'll talk about the different versions. There's 4 versions of them, the S600 V being the heaviest hitter, and that is on newer version of code. Version 10.1 is where that's supported. And these are the versions and the ES or the VMware sizing requirements for those cores and the expected requests per second. And again, if you take a look at the range on the request per second, that's all based on policy and security features that you have turned on. So again, it's going to depend on what you have turned on and how complex your policy is. Now we take a look at our virtual versus hardware, you're going to see quite a bit of difference in all the hardware requirements and the requests per second. So in theory, this helps size your environment for that. Hardware is obviously going to have more horsepower than the virtual for right now, and that'll be expected for the near term. Now, the one thing is we do have, in the hidden slides, you're going to have some information on doing it in AWS, so we now support it in AWS as well for the virtual appliances. Some virtual appliance considerations: don't clone the VMs, don't alter the hardware combinations that are already in there. You don't want to do snapshots that are older than 72 hours. There's no reason to. You want to keep those current. Highly recommend local disk. If you're going over a NAS or SAN for that, it could be pretty painful. You want to keep local disk on it. Don't use thin provisioning unless you're just doing it in a lab environment and don't really care about stability or performance. We do support it on any hardware platform. We will support the actual VM, best effort. If you are on UCS, you do get end-to-end support on that because it's a UCS Cisco supported. And again, don't clone the hardware configs. So now we're going to swing into talking about advanced threat on WSA. So we're going to talk about what is AMP, what is ThreatGrid, how do they work together, and how do I configure all this? What is AMP Unity? So for those of you who raised your hand that you had AMP today, some of these features you may have, some of them are brand new within the last couple months. For those of you who don't have AMP, hopefully you will consider doing an AMP proof of concept after this because it adds a massive amount of security to the WSA. So AMP has a number of components to it. There is an AMP public cloud, and this basically drives all the disposition of the files that Cisco knows about. We can also do it in private cloud, which basically takes that intel and throws it on your local premise. An AMP-enabled integration is something like a WSA, an ESA. We have multiple ones that use the AMP cloud and the reputation services around it. And then there's also ThreatGrid. So when we take a look at this, the three pieces that are done on the WSA, file reputation, file analysis, file retrospection, those are all things that are handled at a security level for all the traffic. So as any file floats past the WSA, we do a file reputation lookup on it. That pings the cloud to say, hey, is this file good or bad? Now, if Cisco doesn't know about the file, we do a file analysis on it. So the file analysis actually sends it up to our ThreatGrid cloud, goes ahead and does a dynamic analysis on it, and gives a disposition on that. Now, what happens when things change? File could be good day 1, bad day 3. File retrospection actually sends a report back down to the WSA that says, hey, this guy got the file on Monday. It was unknown at the time. We now see that the command and control host that piece of malware is trying to talk to are live, and it's now a bad file. You probably want to go check out his machine. So those functionalities are handled with AMP and ThreatGrid. Now we can also do those on-premise as well. So we have a whole bunch of features. Now this slide is actually really painful to look at on here because I put a lot of stuff on it. But in your slides that you can download, you can look at it a little bit closer. But I wanted to show basically what AMP does for all the integrations. And then there's some enhancements to it if you're using our AMP for endpoints or other products. So I'll skip over those because I don't want to make this a marketing presentation. But basically, we have the SHA matching. We do different types of hash lookups for all the files that are flowing through. Executables, PDFs, Office documents, all those are set for that ThreatGrid file analysis. And then we have Talos overall as part of this. Now, AMP for Endpoint has a number of different things as part of it. We won't talk about that today, but I do have another session that I did yesterday that I reference in the slides that you can actually go take a look at to learn more about all this. But the key here is that we have continuous protection for your web traffic. That file retrospection that occurs is a report that you can actually give actionable items to your desktop team to say, hey, this file went through, we know it's bad, you need to go clean it. Now, if you're using other Cisco tools in here, we can go ahead and automatically clean that and pull that out so that it will not activate on the workstation, like they won't be able to open the PDF or execute the executable. So there's some automatic mechanisms as well, but if all you have from Cisco is our WSA, it gives you the information to know what to do with that file that we've seen that it's bad. So you have ThreatGrid as part of this too, and we talked about that a little bit already. The key here is that it's an intelligence platform that does dynamic analysis on software and also has a threat intelligence component to it. So if you have WSA and you have AMP on WSA, you probably want to take a look at the ThreatGrid cloud subscription as well. It's an enhanced offering above the ThreatGrid analysis that goes on that is included with the WSA and AMP licensing that gives you wider threat correlation. So if you're doing threat hunting and you want to find out more about malware, watch that malware execute, all those things, those are all supported within ThreatGrid Cloud. So where does AMP sit in the stack? So the WSA does a number of different security modules. We have the URL filtering, we do reputation filtering, we can take a look at the dynamic content. We have the anti-malware licensing, so you can do Sophos, McAfee, or WebRoot, or a combination of those three. Well, AMP is at the very end of it. So what happens is after all the other engines have taken a stab at the transaction, AMP comes into play. And we do those three things we talked about, the reputation, the analysis, and the retrospection. So we walk through here and we take a look at the very basic flow, what happens. For those of you who are in my session yesterday morning, this will look a little bit of repeat here for a couple slides. So we talk here about the web security appliance. So as a file goes through, it's going to do a file reputation check first. That file reputation check says, hey, have you seen this file? Have you seen this PDF? Have you seen this executable? AMP Cloud is going to respond with the disposition of that file. And this is all real time as that transaction's happening. So before that user even downloads the file, it goes through this process. Unknown, malicious, or clean. If it's unknown and it's a supported file type, the WSA will actually take that file and send it up to ThreatGrid. Now notice I said if it is a supported file type. So WSA will only will only upload PDFs, Office documents, and executables. So those would go up to ThreatGrid, and then ThreatGrid can give a score on that, and then the WSA can act on it. Now the one thing to keep in mind here is that WSA doesn't store these files, right? So once the file analysis has happened and we get a response of what that file actually is, that file is long past the WSA. There's no way to go yank it off the workstation unless you're using one of our other tools. But that's where that retrospection report comes into play. Configuration is super simple. 2 checkboxes, turning on reputation and file analysis. You pick the file reputation, single checkbox. File analysis, you tell it what file types you want to be turned on. And again, those file types are global. So PDF, Office, documents, and executables for right now. Now we get into the actual detailed configuration. So you have the ability to select which cloud you go to. Most of you in here are suspect US. So we have different data centers. You can have the Americas data center or go to the Europe data center. You would select the AMP for Endpoints console integration. We'll talk about that in a bit. That's our Unity configuration. Go in here in the AMP client ID. This is what registers it to the cloud. And then you have information if you want to use a proxy server, kind of funny, from a proxy to a proxy. But if you need to use a proxy to get traffic out, you could go ahead and do that. So again, you select which cloud you want to go to. Very, very simple configuration, about 3 seconds per box. Now in your policies, so remember we talked access policy. You have the anti-malware and reputation section. When you go in here, very simple. You go into the policy and it's either a block or monitor. So what this configuration is for those files that when we do that initial ping to the Cisco AMP cloud of is this good or bad, if Cisco says it's bad, you can either choose to block it or allow it to go through the stack. Why you'd want to allow it, I'm not quite sure, but you have that ability to do so if you want to. This is Cisco saying this file is known bad. Talos tells us it's bad, third party tells us it's bad, ThreatGrid tells us it's bad. You probably don't want to allow it through. So this basically turns on or off the file reputation and analysis for that access policy. So they can all be configured per access policy. So if you want to turn it off for your security group or an IR hunting group, you can do that. And again, very, very simple configuration. It's literally 2 checkboxes. So for the next set of slides here, I have flows depending on where you are putting what. So the AMP services that occur on the WSA can sit in the cloud or they can sit on premise. Same thing for ThreatGrid. And depending on where you put all these things changes the file flow. So I'll walk through the doing it all in public cloud one at a high level. The rest we'll just breeze through those and you can look at those slides later if you'd like. So what will happen is the WSA talks to the cloud. It generates the SHAs and sends them to the cloud. The cloud responds and gives you either that clean, malicious, or unknown. Now if it's unknown, we're going to run it through another set of local engines. We're going to check it with ClamAV locally. We're going to look to see if that file has any active content in it. If the active content is a web or a Word document that is just text, I'm not going to waste cycles sending that to ThreatGrid because it doesn't have any macros in it. There's no active content in it. There's no PowerShell scripting in it. There's nothing in it that would lead us to believe that it's malware. So we don't bother sending that up. But let's say it does have those things. It's a PDF that has macros in it, things of that nature. We shoot it up to ThreatGrid. ThreatGrid's going to respond. Now, when ThreatGrid responds, it gives a score to the WSA. The WSA will do retrospection based on that. But ThreatGrid also updates AmpCloud with that information. So your private file, and again, all your uploads that come from the WSA to ThreatGrid are private samples. Those samples are not ones that other customers can access. However, the disposition of that file, so if we find out that this file is bad, but it's something that's very unique to your company, we will update the SHA within AmpCloud's database that says this file is bad, but we're not going to actually allow other customers to look at the details of that file. They can't download it, they can't look it up, they can't do things about that, but we will share the disposition of that file. So if that file ends up somewhere else, we know it's bad, they can't download it, and likewise theirs to your org. AmpCloud will use that intelligence with other intel to give a final disposition, because remember, ThreatGrid just does the file analysis piece. It doesn't actually tell us point blank at the very end that this file is good or bad. That's AmpCloud's job. AmpCloud will then update the local WSA. Yes?
What do you do with the files after they're uploaded to the cloud?
So all the files that are uploaded, those are retained in ThreatGrid for 2 years. So all the public samples that are out there, or sorry, all the private samples that are out there, a minimum of 2 years. Now, what can occur is, if that's a concern for orgs, which in some it is and some it isn't, for those where it is a concern, we usually show them privacy guides that help lessen those concerns. But at the end of the day, you do have the ability, if you have ThreatGrid Cloud, to go ahead and delete samples and do sample administration too, if you don't want those to stay in our cloud. But the reality of it is a private sample is your organization's own information. So now I have some other flows in here around all the different ways of doing it. So here is the hybrid one. And again, the mechanism and flows are going to be the same, but here we have the ThreatGrid appliance on our local premise, not up in the cloud. So basically all that file analysis is done locally instead of sending it up to us. So if you're a company who has concerns that Cisco's holding onto your files, you could have it on premise. That way they're within your purview. There are some problems with this though, because ThreatGrid appliance does not actually ever update the cloud. So that disposition is never shared to the cloud. So if you have a lot of WSAs, they don't know that it's already been looked at and that it has a bad disposition. So the hybrid can get wonky. Now we can fix that by going full private, where everything is on premise. So the AMP private cloud sits on your premise, and the ThreatGrid appliance is on your premise. Now with those, ThreatGrid appliance does talk to AMP private cloud, so that disposition would be shared across all your AMP devices in your organization. Some of you may have more than one WSA. Some of you may have WSA and ESA, or Firepower, or AMP for endpoints. All this would be shared across all those dispositions. So that's really the best way to do it if you want to go full private. And then we have the concept of an air gap mode where there's no communication to the AMP public cloud. So we talked about ThreatGrid appliance. The ThreatGrid appliance, you want to be on later code on the WSA as well as on the ThreatGrid appliance. And again, this would be for those customers who want to keep all the file analysis locally within your walls. You have the ability to go ahead and add it to the WSA. Once you go ahead and add it to ThreatGrid, you have to activate the account. And then WSA then sends those file analysis to ThreatGrid. Within the WSA, the configuration is pretty simple. We go ahead and we just go in and we tell to talk to the private cloud, give it the IP address, upload the certificate from the box, and we're good to go. So ThreatGrid appliance is a pretty simple configuration. Now again, if you're using ThreatGrid appliance, you likely want AMP private cloud as well. Once the WSA registers with the ThreatGrid appliance, you have to activate it. And once you go ahead and activate it, then your file analysis will go on. You still need to have the feature keys on WSA if you want local ThreatGrid. So you buy the local ThreatGrid appliance, but you still need to pay for the file analysis and file reputation keys on the WSA, known as our AMP licensing. You want to make sure that the configuration is clean between the two. They want to make sure they can talk to each other. And the API key is really important between a WSA and any ThreatGrid implementation, whether on-premise or cloud. So with this, Does anybody in here have AMP for endpoints? Okay, so more, okay, that's interesting. So we had more hands for AMP for endpoints than we had for AMP on WSA. So those of you who are using WSA without AMP but have AMP for endpoints, see me after this session because I want to get a little more information around that and talk about some integrations there. So this here, if you are using AMP on a AMP-enabled product, so ESA, WSA network, and you have AMP Cloud, or basically the AMP console with AMP for endpoints, we have a new feature called AMP Unity. Now, what AMP Unity does is it actually allows you to watch file trajectory across all your devices. So if you had the perfect scenario of a full Cisco system, and you had firepower, and you had WSA, and you had AMP for endpoints, AMP Cloud would actually show that file traversing in file trajectory the network, through the WSA, and on the endpoint. And you'd see that flow, and if you had the endpoint, you'd see when it was executed, when it was opened, when it was whatever. So we might be getting locked in here. So all of that is in there. Now that is requiring some new code. So your AMP firepower appliances and an FMC, they need to be on 6.2, email 11.1, and web security 11.5. So what this does is this actually will register your WSA with the cloud and give you the ability to do global white and blacklisting of SHAs. So what will happen is if you decide you want to block something and you block it in AMP Cloud, it now blocks it across all network, it blocks it across all web, all email, all endpoint. So let's do a quick integration here to show you what it looks like. So in that screen where we configured our AMP file reputation earlier, you see a register appliance with AMP for endpoints. So that will actually open up a window to log into AMP for endpoints. You'll authorize your WSA into AMP Cloud. And once the registration is complete, you now see under computers in AMP Cloud, you'll see your web security appliance. So that web security appliance becomes a machine or computer within your configuration in the cloud. So what this does is this overrides, think of it as almost a shim between AMP Cloud and our global repository of SHAs and dispositions, and allows you to white and blacklist those on top of what Cisco says they are. So this serves two forms. One, in the event a file comes out that's malicious that we don't know about yet, it happens, no one's 100%, we don't claim to be, you can go into your AMP console and block it. And that means your WSAs will now block it. Your firepower will now block it. Your AMP for endpoints will now block it. Single click across the org. Or you disagree with a Cisco disposition and you want to go ahead and say, well, this SHA that Cisco says is bad is not. You can whitelist it. Same functionality across all the board. So when it comes down to it, for those of you who have AMP for endpoints, this is in the AMP for endpoints console. So we now have simple custom detections and whitelisting that we can do for all of our AMP-enabled devices that are running Unity. Unity is a free offering. The only requirement is that you have AMP for endpoints and you have an AMP-enabled device that supports Unity. So it's another feature enhancement to that. Now where it gets cool here is that it'll actually go through and show you that information that the WSA saw that file, or that the endpoint saw that file, or that it's blocked. So you get the device and file trajectory views. So for those who are interested in a little bit more about AMP, I did a session yesterday morning about the same time. I somehow get the 8 o'clock shifts. And BreakSec 2890, we go in deeper into all the AMP integrations and how they integrate together. I go deeper into AMP Cloud, I go deeper into ThreatGrid, and I do a demo at the end of it showing the visibility enhancement that's available with AMP for endpoints and ThreatGrid. Visibility will make your lives a whole lot easier for incident response as well. So take a look at that session. The recording and such will be up in a couple days. The deck is for that one I think is pretty darn good too. So I would check that one out if you're interested more in AMP. So we're getting to the tail end here. We've got about 25 minutes left. We're going to talk about CTA, and then we'll do some Q&A or just open questions. So what is cognitive threat analytics, and how does it fit in the WSA stack? How do I configure it? So let's take a step back and talk about what CTA does. CTA takes all the logs from your proxy, from Cisco's proxy, WSA. CTA also works with third-party proxies, Bluecoat, for example, WebSense, Zscaler, McAfee. We take that log set after the transaction's already happened and take a look at it for different types of behavior. So it fits within the stack. If you look here, you have web filtering, web reputation, AMP sits all the way down here, AMP's at the end of the stack. Well, then we get into CTA. So CTA happens after everything's done, the user's already downloaded it, and whatever. It's looking at logs. It's not actively blocking, it's not doing any of that. But what it does is, it actually boils down all those log lines that you're probably ignoring and puts them into something that's a little more actionable. So for example, your Blue Coat or WSA or whatever is probably blocking a lot of command and control traffic, right? So when my laptop's in corporate and I'm infected, it goes out and tries to talk to a command and control host, proxy blocks it, yay, we win, right? Well, did we though? Because that workstation's infected, right? Just because our Blue Coat or our WSA or whatever is blocking it, our proxy's blocking it, it's still an infected machine. And when they go home or to the Starbucks or whatever, that command and control host is actually happening because they're probably not protected at home. So what this does is, this takes all that information, the billions of log lines a day that are created by your proxy, and boils it down to an incident. CTA has the intelligence to say, well, I see this workstation is talking to these 5 addresses. Now, I'm blocking it because Cisco's file reputation or Cisco's WBRS score for that domain is bad, so they're not getting there. But I see the fact that they're talking to these 4 domains, CTA knows that they're probably infected with X malware, or they have X browser hijack in it, or they have X command and control host that they're hit with. So it takes all those and boils it down into actionable items using a lot of different detection models. So what it does is you basically take your logs from either a WSA, a third-party proxy, or even CWS if you're using CWS, throws it into the CTA engine, and gives you actionable results out of it. Now, those analytics, they're run in the cloud, and the greatest part about this is that, and what I use, and for those of you who have WSA today, or those of you who don't and are thinking about it, or maybe in a POC, ask for an evaluation of CTA. CTA is included with AMP licensing on CTA. So those of you who have, included with AMP licensing on WSA, too many acronyms at this company. So if you have AMP today on your WSA, ask your rep to get you CTA. So what it will do is, we'll take all those logs out, and we've had customers that they had no Cisco equipment whatsoever. They had Blue Coat proxies. So we take all their Blue Coat logs, and we show them what's up. Well, your AV is missing all this. Your Blue Coat's allowing this through. Your Blue Coat's blocking this. And we show them that information, and it gives them a good idea into the security intel of what we can do. And the best part is, it's non-user impacting. So it's the easiest proof of concept you could ever do. You're just giving us your logs, we churn them through the cloud, and we spit out some beautiful reports. So for those who are curious about that, I'd highly recommend talking to your sales team about it. So let's talk about configuration on WSA for it. Now, the configuration is pretty simple. We've got a security service called Cognitive. It brings up an area where you can enable it. And then there's a web UI. The web UI is obviously the cloud side of it, because remember, all the analysis is done in the cloud. So we go ahead into the WSA, and it creates another set of logs. So what it's doing is it's creating a new log subscription. Now, the log subscription has all the fields in it, and we have the ability to anonymize some of those fields. We'll talk about that in a couple slides as well. So we go in here and we get the base configuration done. We already have the server information and everything on here. It uses SCP to transfer logs. So then we log into the CTA side. And we go in and we go to a device account. We say hit a new device account. This session rocks, pretty good name for the session, right? Or for the device. We add it. We go in, we put our information around it, and then we paste the device username that we get from here back into our WSA. And then we'll get a public SSH key that we have to put in from the WSA. So we go back in here, we put it all in, and we're now uploading to CTA. Now we have some customers, largely non-US customers, that get really squirrely about usernames in the cloud. So what we've added in newer versions of code is the ability to anonymize some of these fields. So you can anonymize the IP, you can anonymize the username. So what we do is we actually put in a passphrase in here. The passphrase will be used on all the WSAs to anonymize all the usernames. Now, why do we have this? Well, if we want to de-anonymize, we need to have some ability to do that. Because if it comes down to the point where you're actually going to want to know who this user is in CTA, you can cut and paste from CTA into here to get what that actual username is. So you would paste the encrypted text, put in your the text, put in the password, and it'll give you that data. So Cisco's blind to your username and IP address that had it, but you have the ability to actually chase it down to find out who was owned in there. Now, the de-anonymization is something that is available only in newer code. Now, based on all the hands that we had here, I have the configuration for older versions in the hidden set of slides. So if you download the PDF, there's a number of slides that we're not showing today. I have the pre-11.5 CTA configuration in there, screenshots in there to help with that. So some key things for the uploads. You want to keep the maximum file size small, under a gig preferably. Just smaller uploads just seem to work better with transactions. We recommend uploading those pretty frequently. The larger customer you are, you want to do it more frequently. And again, the transactions occurring from that M1 interface, you can go ahead and override that with a static route if you want. And then you'll actually see within the CTA portal the uploads. So you'll see each proxy. So these are the individual proxies, the blue right here. And you'll see how much is being sent up per day and all that information. So you see that things are being uploaded. So you've done all this, you've configured it. Now what does it all look like? Well, these are some older screenshots, but same concept here. So it's basically going to show you an event, a confirmed event. So what this means is that these machines, these affected users, are infected with this particular threat, this malware family. And we know that based on where the transactions were going and what they were doing. We walk in, we have the investigations, and we give incident levels, so to speak. So a 9 here very likely means that this machine needs to be reimaged. So there's a whole slew of numbers from 1 to 10. And with those, we tell you that this ranking is a 6. It's a 6 because we know that a generic AV will be able to clean it. So you need to get this machine cleaned. Or it's a 9 or a 10. This machine is hosed, very unlikely to be cleaned, probably needs to be reimaged. So we boil that down based on what the threat actually is. We give the information of who the user is, how long they were doing it, all that good stuff. So at the end of the day, CTA is another tool that is within your environment that will go ahead and allow you to give better detail to your organization. Or maybe, just maybe, you have WSA today and you don't have a next generation AV. You don't have a product like AMP for endpoints. This tool will help you convince your leadership that you might need an additional type of security product in the path. WSA can only block so much, but the second that workstation's away from WSA, they're not being protected. So maybe you need to look at a product like AMP for endpoints or one of our other products to help with these things, to clean the actual workstation up. So with that, I have a number of PDFs in here that you can talk, or a number of URLs here. The AMP Best Practices Guide is one that I write in my spare time that talks to how to configure and manage AMP on our integrated security products. I've got some threat grid install guides, how to hook all that up together, WSA end user guides, and CTA. So with that, we're actually about 15 minutes ahead. I expected more questions, but I'd like to thank everybody for hanging out with me this morning and making it out here. Like I said, we do have the surveys. Please do fill those out. We've got the chat room. And if you do have any questions about your WSA, I actually used to support email in a previous life here as well, or any of the AMP stuff. Feel free to come on up and chat, or we can do the Q&A in here for the next 10, 15 minutes. But thank you, everybody.